All right, guys. Oh, this isn't right. This isn't your work. Hope you guys are well. I'm just going to do a quick register. So let's do that. As soon as it loads. Wow, loads of you here already. Good, good, good. Okay, where's the Moodle? There. And your attendance should all be ticked off for Wednesday as well now. I think I did that this morning. Cool. All right. Save draft. Okay. So we have got Jay. We've got Danny. We've got Harry, Billy, Louis, Scott. Where's Scott on the list? There, Scott. Nuala and Guy and Lucas and Elliot and George and Callum. There's still loads of you. And Lucy. And my list isn't alphabetical. Where's Lucy? There, cool. And where we got to Ollie. Ollie, it says you're not here, but you are, so cool. And Becky. Becky, where are you? There. So, no Tom from what I can see. Still no Chloe. Tristan, no Tristan today. Alright, I'll leave the rest of you for a bit. No Jake, no Isaac, and no Kieran. Alright, cool. See what happens. So, today I thought we'd start with where we left off last lecture, which I believe was here. So, I think this is where we're at. We might have started it, but yeah. So, got a bit of coding. We're still looking at our correlation and regression. Could you guys give this a go? So, it's a 4 marker. There's 3 bits, 3 marks for the first bit, which is kind of like a log to linear form question. And then we'll try pop B after that. So, I'll set a timer for 4 minutes and we'll see how you get on. Comment if you need any help or when you've got some answers. Anyone need any help so far? And we have Kieran, Isaac, Jake, Tristan, or Tom yet? added you, so don't worry. Cool. All right, let's have a go for this one then. So we've got some data, and they've found a regression line of y and x. Given the data can model this form, find a and b. Okay, so this is basically a log to linear form question like we had back in pure maths. So we're going to log this equation and then compare it to this equation and use it to find a and b. So we don't actually need any of that data in the table at all. So d equals a b to the t. So we're going to split this up and take logs of everything. So log d equals log a b to the t. So we get log d equals log a plus log b to the t. And we use the power rule on that to get log d equals log a plus t log b. Cool. All right, so now we can compare this equation here with this equation up here, comparing this one with this one. Now they told us x is t, so okay, let's just pretend that this x here is the same as this t here. And y is log d, so this y here is log d here. We need to find a and b. Well, if we look at the a part, a here is on its own with no t's or x's or anything. That must be the same as the bit in the other equation that's on its own with no t's or x's or anything, this bit here. And the log b bit is multiplied by t. And we know that t was x, so log b is going to be equal to the bit up here, which is multiplied by x. So by setting those things equal, we can actually solve them. So I'm going to do that under this bit. So we're going to say minus 0.635 equals log a. And remember, log without a base is log base 10. So I can say 10 to the power minus 0.635 is a. I can do the same thing with b. So I can say 0.0334 is log b. So 10 to the power 0.0334 equals b. And I can use that to find a and b. So calculator out, 10 to the power minus 0.635. So we get a is 0.231. Oops. And b is going to be 10 to the power 0.0334, which is 1.08. The wrong color. But yeah, so there's b, and there's a. Okay, explain why the model is not reliable for estimating the amount of dry residue produced when the temperature is 151. This is what we talked about last time, that if you're estimating outside of the range of your experiment, and our range stops at 94, so 151 would be extrapolation, and it would no longer be accurate because it's outside the range of our data. So I'll try and write that, but there's not much room on here. So extrap data goes to 94 and then should not estimate past this. So it's too far outside the range of our data to be considered valid. Cool. Is everyone okay with that? So that was a brief recap of what we did last time. I think we looked at this one. So we looked at finding correlation coefficient. Um, I don't know how, because last lecture was the one where we had all the lag issues. I managed to fix that now. I'm sorry about that. It's something I did. I tried to stream at too high a resolution for the delay time on YouTube. So that's fixed now. But could you all understand what was going on last lecture? Have you tried rewatching it? And I know the lag's gone. I think the audio is fine, but the video of me is still a bit lagged. Um, do you guys have any questions now that you want me to go over from last lecture? Because I still have these are the slides from last lecture. If you do want me to revisit any of those topics, because I know we didn't. It was a bit of a struggle towards the end of Wednesday's lecture. So please ask now if you do have any questions. But remember, we got correlation, which is the relationship, how strongly the relationship between two variables resembles a straight line. So positive correlation, one would be perfect positive correlation, which shows it's a straight line like this. R is minus one would be perfect negative, which is a line like this. And if your data is all kind of spread out, your values get further away from one or minus one. And zero would be no correlation. And then we had the regression, which was a regression equation, which is an equation that's the line of best fit. And we showed how to do that on the calculators, put in the two values as two variables, and then use two var analysis to find out A, B, and R, and then you can predict things. And if you're predicting inside the data, it's interpolation, which is reliable because it's between values you already know, which is what we did with the median. If it's outside your data, like that question we just did was, it's extrapolation, which is bad and unreliable. And the other thing we said is when we're doing regression, we're finding a line of best fit, which we say is R. It's the final line of best fit, which says y equals something x. That's the line y on x. And you shouldn't use that to predict x values when you know y, because the variable is the wrong way around. So remember, it's dependent variable, independent variable on the x, and dependent variable on the y. Has anyone got any questions about what we did last lecture? Because no one's typed anything, so I'm assuming you're okay. But yeah, did everyone? Can you just type a yes if or a thumbs up or something or a smiley face if you got the gist of what we were doing on Wednesday, even though the lag was extreme? Yes, yes, smiley face. Three of you, three out of 22 is not too bad, I suppose. Okay, yeah. Keep typing it. Yeah, okay, lots of yeses, right. Let's go with that. That's fine then. Okay, so this brings me on to today, and there's a few messages and notices. So Jay, kinda rewatch it, Jay. If you're still not sure, next week we can do a one-to-one and go over it. That goes for any of you. If any of you want me to go over that stuff again, we can do a one-to-one bit on it. So save that. So, as of next week, at some point, I need to do this and put it up. Assignments will be available to submit on Moodle, and you'll also be able to submit your skills checks on Moodle. So, skills checks and assignments will be back, all being done via the Moodle website. So, we will be looking at that at some point soon. So, yeah, the assignments still will be happening. The next bit, we're going to do a couple more questions in a minute, but I thought for now, let's go through stuff. Can I bring it up on here? No. Hang on. Give me a sec, guys. I'm just gonna find the information I need to share with you. Where's it gone? Just lost my email. Here we are. Okay. So you guys should have been sent an email today about exams. So during the week, the 27th of April. So let's just write this down quickly. So 27th of April. you guys are going to have your tests. The ones that we were going to originally have a week before that on the 20th of April, you guys will now have on the 27th of April. And you're going to have to do these at home and in exam conditions. So I think what we'll do, the papers will be put up on Moodle. They'll also be emailed to you, but you guys are going to need to do it and either scan it or take photos of your workings so that I can then mark it. And that's going to be your grade for the year. So these are pretty important tests. And you guys, I mean, it's not too far off in the future. So hopefully you've all still been revising um, since like college stopped. That test will be just on pure maths. So the stuff, it'll be similar to what was in the mock that you guys did. I haven't marked the mock because the mock is at college, and the day I was going to go get it was the day the government told us we couldn't travel unless it was for essential reasons. So not sure what I'm going to do about those. I think it's unlikely I'll be able to get those papers marked for a while because they're in Truro and I live in Newquay. So yeah. But yeah, so main thing though is you need to get revising for that paper on the 27th. It'll be the week beginning the 27th, and it'll be up to you guys to do it whenever you like. You'll have from Monday the 27th until Thursday the 8 a.m. in the morning on Thursday of the 30th of April. If any of you don't think you'll be able to download a paper or either scan or send me a paper, let me know because that could be some issues. The other option is you could post it either to college or to me, which we can do, but and I know it's a pain in the neck, but these are weird circumstances. So you should have had an email, or you should be getting an email shortly from the college. They only told us today, so if you haven't had the email yet, don't worry. I only got told about this at 12:30, so I got told about it like 2 hours ago. So these emails will be going out to staff. But yeah, if I guess I can just show you guys the email if you want. That seems allowable. So give me a sec. I'll see if I can copy this in. But yeah, if you got any questions about it now, let me know. But I will just put this in the message. All right, let's snap that one and put that in Google. Cool, and now let's try and add that. Oh, not Dropbox, that's not what I wanted to do. Google Drive. Cool, okay, and Jake, yeah, the lecture's always going to happen at the same time, so it's not a very good excuse. Log on to the YouTube. If you haven't had a link, it will be happening. So in future, go to the YouTube rather than wait for any email. No, you're not going to have any lectures that week. So I don't know if you guys can see this. Let's just go through it. So if I get rid of that writing for a sec. Right, so during the week, there'll be no online delivery for A1 students. Instead, this will be the week that you complete your A1 assessments. So lecturers will be available for revision support from Monday to Wednesday of the week, but not available on Thursday or Friday, I assume, because that's when we're going to be marking those exams. You'll find your assessment materials on your Moodle page from Monday the 27th of April. So that's the Monday, I think, that we come back. No, the week after we come back. They'll be emailed to you in the morning as well. You need to complete it between Monday and Wednesday. You should email or post it to your lecturers as soon as possible. Okay, we're aware that some students may not have printing facilities, so you will need to follow the instructions on your assessments carefully, and you'll be able to handwrite or word process your answers, which I know is a pain in the neck for maths sometimes. But yeah, if you have to handwrite it, take photos. It's not the end of the world. You can help us give you the best feedback by doing these examples. So make your answers as clear as possible, whether they're handwritten or word processed. Leave spaces between questions and question parts. Clearly label your answers. So I think what I'll try and do is get you guys the version of the test that has space for your answers to be written, like you had in that mock the other day, and then you can just write on there, and then either take a picture of it or scan it. Or if you fancy typing up, you can, but I think that might be a bit of a nightmare. Okay, we want to reassure all students that these are challenging circumstances and that we want to take our tutors to support you. So there will be some revision there as well. You'll be able to get feedback on it, but we do want you to take it seriously and prepare as if it's a proper exam that you do in college. Yeah, so here's some tips. Decide when to sit each one. Choose a time when the chances of being disturbed are minimal. Create as much of a formal examination atmosphere as you can. Set a timer so you can try and do everything in the set time. And tell the rest of the household when you're doing it. Cool. And we recommend that you do it in the morning or the afternoon so you're less tired, because people do get tired in the evening. So yeah, if you've got any questions about that, let me know. But you should be getting this email shortly, and hopefully that makes sense. So that's 27th. It's been pushed forward a week to make up for the week of chaos we just had. But we're exactly where I wanted us to be at this point in the year. So we'll have a week of revision, I think. Let me check the scheme of work. I think we'll have a week of revision. Oh, where's that? There it is. So yeah, we're pretty much where we should be. Yeah, we'll have a mock revision week. Maybe the week after Easter, or at least a few lectures of revision. And then you'll be doing the mock papers. So yeah, cool. So yeah, there will be some time to do some revision. Okay, what's Cam saying? Are we going to do any other exams in the hall before our actual A levels? Next year in January, February, you will have a proper mock exam in the sports hall. So don't worry, there will be one before your actual A levels, but obviously this year that's gone out the window because of coronavirus. Any other questions, guys, before we get on with some mathsy bits? No, everyone all right? So the main thing is to revise. Look through, there's past papers on Moodle, loads of them. So after the probability bit on Moodle, there's tons of past papers. I'll show you it in a minute, actually. But yeah, so there's loads of stuff you can be getting on with, especially while you're kind of stuck inside. There's loads of stuff that you can be using to revise. Right, anyway, so we've got a couple more questions I want to do, just to see how you guys get on with these. So if you could try this question. So you've got some data, fuel consumption and engine size. Calculate the PMCC and then interpret your answer. So if you guys could try that, 3 marks. I'll be generous, give you 4 minutes to do it. So if you could try that, and then we'll go through that in a minute. Comment your answers when you have them. Cool. Yeah, George. So first bit, yeah, but part B, I would say your interpretation could be better. Whenever it says interpret in a question, it means link it back to the modeling going on in the question. Lucy, yes, slight improvement on George's answer there, but still, you've mentioned the variables, but what's actually happening to them? What happens to each variable? So yeah, neither of you have got that second. You both got 1 mark out of 2, but neither of you got the second mark out of 2 for part B yet. Right, so let's have a look at this one then. So use a calculator to find the value of the product moment correlation coefficient between C and F. So we're going to type this into a calculator. If I bring mine up on screen, I got the graphical, but you can do this on the class quiz as well. So if you go exit, cool. I'm going to have to delete all this. Delete. Cool. So let's put it in. Which one do you think is the X value then? So we got to choose. So what causes what? So I think a larger engine size will cause fuel consumption to decrease. So let's go for 46. Sorry, engine. No. Okay, yeah, engine size first. So we'll go for 1,000. And normally the independent variable is on the top. And you can see as well, this data has been measured in terms of the fuel the engine size. You can see it goes up in hundreds, so it's more likely that you've got that it's actually been set up that way to use those data points. So put the rest in. So we got 46, 42, 43, 39, 41, 37, 35, 29, 28, 25. Is that it? Yeah, cool. So again, we go to calc. We need to set it up. So set up, make sure you've got list 1 and list 2, which we do. So just so you can see that, make sure you set this bit up. We're looking at 2 variables. So we got list 1 and list 2. We need to tell those to be the right way around. And then go exit, and we're going to do reg and x and a plus bx. Not that we need that, we just want the PMCC, don't we? So PMCC, product moment correlation coefficient, is, as you guys said, minus 0.972. But yeah, R equals minus 0.97. Okay, so let's have a look at some of these answers that you guys have suggested. So you said strong negative correlation. I agree. Okay, yeah, and then you said the larger the engine, the lower its fuel consumption. Yep. As one goes up, the other goes down. So yeah, as engine size increases, fuel consumption yeah, I don't This is a badly worded question. Because they've said that F is the fuel consumption, but it's not really. It's the miles per gallon. It's the okay, it's the fuel consumption per gallon. Okay. So as engine size increases, the yeah, I don't like that. Because it's consuming more fuel, the fuel consumption increases. But it's very badly worded. As engine size increases, the I guess we've got to word it like that. It's stupid. The miles per gallon decreases. I don't normally you'd say fuel consumption decreases, but that's not true. The fuel is being consumed faster. So yeah, this very badly worded question, bad at Excel. But yeah, you get the gist of it. As the engine size increases, the other number decreases, which is the MPG, so it's getting less efficient. But yeah, you could argue about this one a bit just because of how they've worded it. It's not a very good question, like I said. Cool. All right, we're going to try one more of these, which is this one. I don't think we did this one yet. So we've got some logs here. We've got PMCC, and we're going to try and come up with a line equation. So 3, 6, 7, 8, 9. 9 minutes for this one. Give this a go. Comment if you need any help, but it should be pretty straightforward. It's kind of like what we did in a starter. So first of all, find these log values. You don't need to comment those. Calculate the PMCC for the log data, and then try and state whether the model's a good fit, and then determine what K and N are based on your regression equation that you find in part C. So give it a go, 9 minutes starting from now. Comment your correct answers when you got them. No, because we're still plotting. Well, some of them aren't linear data, so the non-coded data wouldn't have a linear correlation. So yeah, they would be different, but it's not they would be different. We wouldn't have. Let's just draw a picture. Exponential curve, not linear. If you log it, the logs turn it into a linear curve. And now you can say, oh yeah, it does have correlation, but only when they're logarithmic. So yeah, that's why yeah, they would have different, but you wouldn't get much correlation for for the exponential part of the curve. Same with coronavirus. You wouldn't try and model a coronavirus with a line. But if you logged it, you could model it with a straight line. So it's a nice example of log to linear form, if nothing else. Oh no, what have I done? Trashed it. Cool. All right, 20 seconds left, guys. Do you need a little longer? I haven't seen any answers yet, so we'll delay it another couple minutes. 2 more minutes on the timer. Cool, another minute and a bit left, guys. Part C. So you need to find your equation for part B, and you need to take the y equals k to the take kx to the n, and you need to log that and then compare your coefficients. Basically, compare the two equations like we did in the last example. There's nothing we can do about it. We just have to trust you. So self-exam condition, yeah. There's nothing we can put in place. Yeah. So please do it properly. Basically, I'd rather you didn't have your notes open or anything. It doesn't prepare you well. If you guys cheat in the exam, then you're only cheating yourself. But that's true. Like I won't know. It'd be like going to your doctor and lying. Like it's the same thing. If I don't know where you guys are, how are we gonna support you to move into second year properly? So just please do it properly. Basically, we trust you. You should be mature enough not to cheat. So, all right, let's do it. So, part A, log all this stuff. I'm not going to go through how you do that, but I will copy the correct answers in if I can fit it. Yeah, we'll try and squeeze it in. So, 0.4771. There's no way this is going to work. Actually, maybe I can. 0.602, 0.7781, 0.903, and 0.10413. Okay, and log M 1.31 1.3617, 1.602, 1.903, 2.1673, and 2.4232. Cool. So those are our values. So I typed those in. If you calc, go to regression equation, find x plus b. PMCC should come out as 0.9995, so super strong correlation here. So 0.9996, so very, very, very strong, almost perfect correlation. Okay, then with reference to answer B, state whether it would be a good fit for the data. So yeah, it would be a good fit for the data. The data is linear when it's logged. So when it's not logged, it's exponential. So that's what we'll write for that one. So part C, linear data when logged means it's exponential model. Is good for it. Okay, and then determine the values of k and n. So we're going to write down our regression equation. So we get log w equals minus 0.246 plus 0.532 times log m. So we get that. And we're going to compare that to our equation here. So we got the equation y equals kx to the n. I'm going to log this red equation. So we'll get log y equals log k plus n log x. Okay, so let's compare these things. Cool. So log k must equal this, and n must equal this. So we don't actually need to do anything with n. N just is 0.532. And k, we're going to do 10 to the power minus 0.246 to find k, and k should come out as 0.568. And I'm in the way of all of this stuff. Cool. Right. Anyone got any questions on this one then? How far should we round log and w? In the table, it doesn't say. So three decimal places maybe. I've done I've done a massive mix of things there. Yeah, 3 decimal places would be fine. Any other questions, guys? Cool. Right. All right. So that's all the ones I had planned for today. There's a few more things I need to talk to you guys about. So one thing that's coming up is you're gonna have to do class reviews, which is to review. What does it say? We just got the email through. You have to do online surveys for all your courses, and these need to be done ideally over Easter. So there's a few bits of work to do over Easter, which I'm going to set you now. So first thing, let's show you how to do this. So I think, does this work? Yeah, there we go. Cool. Right, if I show you on intranet. So there's a student survey that should be here somewhere. I don't know if this will work for me, but if you click on your waffles, that's what we call these things. Yeah, then go to surveys. You should see a student survey. Yeah, I don't have any because I'm a lecturer. But yeah, students for learners. So if you click on this, oh, I've got some already. Cool. You guys can then. Oh, 4 of you done it already. Well, cool. You can basically you're reviewing the content of lectures. So reviewing me, my teaching, and everything like that. So if you guys could click on there and do those at some point. Let's have a look at one. No, I can't see. Basically, all I want you guys to do is be honest with it, and if you're going to put something negative, back it up with a reason because we all want to improve. So that goes for any lecture. If you put anything negative in any lecturer's feedback, say why, because we like to be good. We like to improve. So let me know if there's anything you think I can improve on. So there's that needs to be done at some point. Let's just turn this back to the whiteboard. Cool. So there's that needs doing. The other things that need doing is need you guys to what's the word I'm thinking of here? I need you guys to revise. That's the word for exams. Complete assignments. So we should have had one. We're a bit behind on assignments, but basically just need you guys to keep working your way through them. This week it should have been. Oh, is it on this one? No, it's not written down. What week are we on? What number is this? No, I don't have it written down. But just keep on with the assignments because I know we're probably behind by a week or two. So if you guys could go back to those, there will be a slot on Moodle soon for uploading them by the end of next week. I will at 24. Yeah, that does sound about right. I'll put those up on Moodle. I'll email you guys when that's there, and then you can upload the assignments and the skills checks to Moodle for me to look through. The other thing I'm going to set you is this large data set analysis task. So large data set analysis task. Okay, so let's talk about this thing because this is going to be new to you guys. So I've built it's like a 4-page task that revises all of stats up to this point because we are now we're through a big old chunk of stats. What we got left is probability style stuff, which is a different type of thing. So to revise all of this, I thought, right, let's actually give you guys the data set and get you to do a study on the data set. So where you're going to find this thing is, let's go back to here. If I go to Moodle, and then I go to here, we scroll down. Which week is it? Is it correlation regression this week? Oh no, this week probably. No, it's not that. Right, I'm going to put it in week 25 right now because it's currently. Oh, can I do this? I'll put it up in a minute because it's not there at the moment. It will be in this one though. It will be in week 25. So I'll put it in there as well. Oh, is it on the wait one more place it could be because I thought I put it up here already. Important resources. No. Okay, well whatever. The data set itself is available in the important resources part of the system. So if you click on important resources, scroll down, the large data set is here. There's the easy printing one or there's the main one. So I want you guys to download a copy of that. And then you'll see this task, which is what I put here. So you can see this is page 1 of it. I'll just get rid of this. So this is page 1. Cool. And what's asking you to do? So exercise 1 says a few different. I think there's 4 parts to it. Take a sample of size 20 from large data set. Yeah, and you can use any random type you want. You're going to use, there's going to be 3 different sampling tasks. I'm going to ask you to do all three random types. So you're going to code your data using this coding. So you put your humidity, your visibility, and your coded visibility. Then you're going to find the mean and standard deviation of it. So that's all there. Then you're going to do this one, and you're going to uncode your data and find to find the uncoded mean and standard deviation. Then you're going to state the variables, and then you're going to do a scatter graph for your variables. so XY scatter graph, and we can use that to state the correlation from the graph. You could go on further there if you want as well. You could actually calculate your correlation coefficient and calculate your line of best fit. So that could be a little extension if you fancy practicing that as well. Then is exercise 2, which is based around Rainey-Camborn. So you're going to use, this is back to one variable analysis. So you're going to use a different sampling method to sample 20 data points from Camborn in 1987, collect the data on a total rainfall, group it in this table, and if you want, you can resample any TR ones, or you can make them 0. It's up to you guys. Then we're going to use another random sampling method to get 10 for Camborn here. And then we're going to do 2 box plots for 2015 and 1987 to look at the quartiles and the different methods. So 2 different box plots there. Okay, and then the last bit of this shouldn't take too long. I reckon it's about two hours work maybe, if you do a good job of it. Then you're going to check your data for any outliers using those equations there. And then you're going to, the box plots goes here. So the other bit was there. Then you compare your box plots, making statements about the central tendency and spread. So it's a nice use of an example for all the statistics that we've done. Because at the moment, we've just talked about it. I want you guys to actually put it into practice and do a little study, and it will get you used to the large data set. So this is going to be homework basically for Easter. So over Easter, you've got revision to do. Do that survey for me. Keep going with the assignments and get this study done. So you've got those to keep you occupied over the next few weeks. So there's that. Yeah, and then you're going to submit these on Moodle so I can have a look through and mark them. Just check that you've understood everything in stats so far. So that's the goal here with this task. So yeah, that will be uploaded. I'll do it literally straight after lecture. That will go up, and by midweek next week, I'll put the upload form for that and the upload form for all of your assignments and skills checks, so that you can keep doing assignments and skills checks. Yeah. Cool. Has anyone got any questions? Because we're going to end early today so that you guys can start this thing. So I'll go put it up now so that you guys can start getting stuck into it. And if you need any help, you can just message me or ask me, and we can do a Teams chat at some point. So anyone got any questions about that, the exam, the survey, or how assignments are going to work? Anybody? Oh. This one by end of Easter, so that's 2 weeks time for this one. Revision, you've got Easter, 1 week of revision, and then it's your exam week. And I think, is that right? No, you go back. So Easter, then 2 weeks, then exam week. So you got a bit more time for revision. And with the assignments, I will check which ones we should be on. But obviously, because things have been a bit of a mess, yeah, it is a bit kind of skew-if. But as long as we get those finished by the end of term, I don't mind. But term's kind of vague at this point. So I'll put everything up, and you can work, if you want, you can work through the assignments at your own rate, because the teaching we've been keeping up with, but because of me being off, like, and this, we're a few assignments behind. So I'll send you an email of where we should be in terms of assignments. So this, yeah, you got about two weeks to get this done. So we'll say the Monday after, so Monday the 16th for this one. Let's write that down. And that's uploaded onto Moodle, so I can download it and have a look at it. Right, any other questions, guys? If not, I will go over to Moodle and put this up so you guys can get started on it. If there's any questions, just get in touch. Cool. Right. Thank you, guys. You too. Stay indoors. Don't go out too much. And yeah, speak to you in a couple of weeks' time or over half term if you need any support between now and then. Thank you. Cheers, guys. Bye.